Welcome to Study Loop.
So here what we have is a camera, and we have its distance to a rocket, and we could draw this. And this is a height right here that we have off the ground. So this is h, and we'll shorten that up a bit. Then we know that this distance right here is 4,000 feet. That's 4,000 feet from the launch pad, and the launch pad is right here. This right here is going to be our x distance. So we know some initial conditions of 3,000 feet being our h value, this height. And we know that the change in height with respect to time is 600 feet per second. And we want to know the rate of change in x, so how far it's going away from the camera. So what we do is we find a relationship. We find this relationship between x and h. That's Pythagorean theorem because what we have is a right triangle. So x squared equals 4,000 squared plus h squared. We differentiate that, so we get that 2x dx dt equals 2h dh dt. Then we solve for dx dt, and we get h over x dh dt. Now we know dh dt, we know h. The only thing we don't know, which we need to know, is x. So the way we find x, this specific moment in time, is we have that x equals the square root of our 4,000 squared plus 3,000 squared. That's 3,000 squared because we know that at that moment in time, that is our h distance, because we have the 3,000 and the 4,000. That ends up giving us an x value of 5,000. So now we have our x, we have our dh dt, and we have our h. This can all get plugged into our equation, and we end up getting that our dx dt is going to end up equaling 360 feet per second. So that tells us that the change in x with respect to time, it's changing at a rate of 360 feet per second from the camera to the rocket. Then for part B, we want to find the rate of the angle change. So we know that the tangent of theta is equal to h over 4,000. Taking the derivative, we get secant squared theta equals 1 over 4,000 dh dt. So therefore our, and then this is d theta dt. So then d theta dt equals a cosine squared theta over 4,000 dh dt. Because we multiply both sides by cosine squared theta. So then we take the, we need to find the specific moment in time because we already have dh dt, and we already have, we need to find our theta value. So we know that theta is going to equal the inverse tangent of h over 4,000, and that's going to give us an arctangent. Since h is 3,000, we know that this is going to be the inverse tangent of 0.75. So that gets plugged in because now we have our theta, and now we have our our dh dt from before, which is 600 feet per second. So when we plug all that in, we get d theta dt equals 0.096, and remember the units, that's radians per second.